In the last video, we have seen how the change in the state of the system can be brought about by doing the work. Now, in this video, we'll discuss how the thermodynamic change in the state of the system can be brought about by adding the heat. Okay. Now, the state of the, as I have told you, the state of the system can be changed by adding the heat. Now, for that, let us consider a system consisting of an ideal gas confined to a cylinder with movable, massless and frictionless piston. We want to change the volume of the gas from Vi initial volume to Vf at constant temperature. Now this can be achieved by two methods. Let us first discuss the method 1. In this method, the gas, you can observe that this is state 1. The gas is enclosed with initial volume V1 and you can observe the massless frictionless piston. Okay. Now this is state 2 where the volume of the gas is Vf. Vf is greater than Vi. Now this can be achieved by heating the gas slowly in controlled manner. Due to this, now whatever heat is given to the gas is used for the expansion. Due to the slow and controlled kind of heating, the excess heat is given to the surroundings and therefore the temperature is remaining constant. In this way, the gas reaches the final volume Vf isothermally. That is, now the heat is given to the gas. You have already learned the first law of thermodynamics, that is delta Q is equal to delta U plus PdV. Now here delta Q, that is heat given to the gas, is completely used to increase in the volume, that is for doing the work PdV, and therefore there is no change in the internal energy. Delta U is 0. And since there is no change in the internal energy, there is no change in the temperature, and therefore this expansion of the volume from Vi to Vf is completely isothermal. Okay. Now during this process, the system is absorbing finite amount of heat. So this is the method 1 of addition of heat for the change of the state of the system, that is for the increasing the volume of the gas from Vi to Vf. Let us consider the second method. Now in the method 2, we have, as shown in the diagram, we have a gas cylinder surrounded by the insulating material. Okay. Now this gas cylinder is divided into two compartments. Now let us call this compartment as X and this compartment is Y. The compartment X is having volume Vi and the compartment Y is having volume Vi dash, such that Vi plus Vi dash is equal to Vf. Now the compartment X is fitted with now this compartment, the two compartments are separated by a thin breakable partition. Now the compartment X of the cylinder is filled with same amount of gas at the same temperature as that in the first method. Okay. The compartment Y is completely empty. There are no gas particles or no any other form of matter in the compartment Y initially. Now the initial state of the system is same as in case of the first method. So in method 1 and method 2, in both the methods the initial state is same, that is the volume of the gas initially is Vi at same temperature and the amount of the gas is also same. Now this partition separating the compartments X and Y is suddenly broken. This causes sudden uncontrolled expansion of the volume of the gas. Gas suddenly expands and it occupies the complete volume equal to Vf. Now as you can observe that the gas is occupying the volume that was initially empty before the partition was broken. Now since the gas cylinder is surrounded by the insulating material, there is no exchange of heat between the gas and the surrounding environment. The final volume of the gas, as you can observe in the diagram, is Vf. Now in this case the gas has not done any work for the expansion. Why? Because there is no movement of any kind of piston, no displacement of any kind of piston, and therefore there is no work done. Also, since there is insulating material around the gas cylinder, there is no exchange of heat. So work is not done during the expansion. There is no heat exchange during this expansion. So this such kind of expansion is known as free expansion. It is experimentally observed that when the ideal gas undergoes free expansion, there is no change in the temperature as well as there is no exchange of the heat. Therefore, the final state of the gas in this method is also the same as in the first method, that is the change is taking place isothermally as in case of the first method. The intermediate states of the paths during the change of the state in the first and the second method are different, but the initial and the final states are same in both the methods. The initial figure 1 and figure 2 both represent two different methods for taking the system from initial state to final state. In other words, we have two different paths connecting the initial and the final states of the system. In case of the method 1, there is an exchange of heat between the system and the surrounding because as I have told you, the process is controlled, the heating was controlled and there is no change in the temperature, the process of was isothermal, so there was exchange of heat between the system and the surrounding. In case of the method 2, there is no exchange of heat between the system and its surroundings or surrounding environment, and also the system does not do any work. So what we can conclude? We can conclude from these two methods that the heat transferred to the system depends upon path. We are going to learn more about the free expansion in the next lecture. I hope you have understood this point that the heat transferred to the system depends upon the path and just not on the initial state and final state of the system.